This is an example of a variation function taken from chapter 7 of our text. Again, what we want to remember for a variation is that if we have a direct variation function that implies multiplication, so that would be like y is equal to k times x, whereas if we have inverse variation, that implies y is equal to k divided by x, where k is the constant of variation. What that really means is, at least for a direct variation function, that it's a slope. For the inverse variation, we have a rational polynomial function, which implies we might have an asymptote. Alright, so this problem says that the volume of a fixed amount of gas at constant temperature is inversely proportional to the pressure of the gas. So that tells us that the volume is our dependent variable. Tells us that the pressure is going to be the independent variable. And it says that we have an inverse relationship. So we know that V should be equal to K divided by P. So for this particular problem, it says volume in terms of pressure, again telling us volume is dependent upon the pressure. If it's 46 pounds per square inch, that's a pressure, and a volume of 360 cubic feet. So we're going to plug those values in to find K. So 360 equals K divided by 46. So we take 360 times 46. K is equal to 16560. So our particular equation is going to be V will equal 16560 divided by P. It says what pressure would be necessary to compress the gas to a volume of 276 cubic feet. So that's a volume. So we're going to say 276 should be equal to the 16560 divided by P. So we have a variable in the denominator, and as we've seen several times, we want to multiply by that denominator to get it out of the denominator. And then now we just have P times 276 equals 16560. So when we divide by 276, we get that P should be equal to 60, and that's in PSI. For the next question, it says, according to the model, could you compress the gas to a volume of 0? So could we have a volume of 0? And that says we have 16,560 divided by P. And basically what we do is we look at the fraction and say I have a finite quantity, 16,560. Is there anything I can divide that by and get a value of 0? Well, the answer is no, and that's because there is a horizontal asymptote at 0. I can't divide 16,560 by anything in order to get an answer of 0. So if we were to look at a graph of this function, what we would find is that along the x-axis there is a horizontal asymptote, and that's because the degree of the denominator up here is 1, the degree of the numerator up here is 0. Since the degree of the bottom is higher, that tells us our asymptote should be at what's typically y equals 0. In this case it would be v equals 0. And that is the explanation for our variation function. Thank you.